utilize NRZ modulation format in our industry for the last decades, serve us really well. Now start really getting to the so-called PAM4 transitions. And certainly currently, all the 100G solution is based on so-called 4 by 25 gig transition using the NRZ modulation. So this is a very familiar modulation format. If you're looking at this company on Inphi, they actually logo their company on this MRZ line diagram. But I do know the Inphi people in the room here, you may have to start to change the shape of the logo soon. So one thing we actually deal with this NRZ modulation is we actually have to use a fairly complex and high-cost way to construct the module, because now to go 100 gig, you actually have to use multiple elements to construct it. And in this example, it's a TSM4. You actually take 4 parallel lanes of optical channels, and then you combine them, and they're coming out. One flavor is you just take straight 4 channels out and 4 channels in, so this is called parallel signal fiber, and 4 just spans like 4 of them. Then another application or incarnation is just take 4 of them at different color, so-called CWDM, and then you combine them and using so-called WDM filtering, and then you actually reduce the number of fiber. But each of these constructions require complex packaging. So what we're looking at as an industry is how do we change from this MRZ modulation format to a more efficient 4-level modulation format, so-called PAM4. And this is critical for us to scale to 100 gig by using a 4-level modulation, but also need to increase the baud rate. Because that way we give factor 2 from the baud rate, and then factor 2 from the 4-level modulation. And this is important for us as industry to reduce the cost, but also setting the foundation for the next 400G. Because now we can use that single lane and then multiply 4 times to get the 400G. Actually, we just announced 100G Lambda MSA just Tuesday last week. So this is a brand new multi-source agreement. As Andy said earlier, this is one of the most important MSA we just announced for the industry. There are actually a total of 22 companies actually endorse and support to promote this MSA. So certainly I think from the promoter or starting company point of view, this is almost unprecedented. This large number of companies actually using this 100G on the MSA. And it's a good mix of module suppliers, component IC suppliers, and also system OEMs, and even including some of the end users like Alibaba and Microsoft. And this MSA will define 100G for the R and FR, and then also including 400G LR4 and also FR4. And the key benefit here is we certainly like to achieve the goal here is to reduce the cost for constructing the 100G and 400G products. And this is also a very important element here, and they also eloquently outlined earlier is sooner or later the SerDes technology is going to make progress, and eventually the SerDes is going to support 100G single link. We certainly do not want to be in a situation where we have to do an inverse flux, then going down to the optics, and this has become very inefficient. So we need to prepare the advancement of the SerDes technology going forward as well. So single lane 100G allow us to there scale that moving forward basis. Important element is then we lay the foundation for a much improved 400G and even higher speed. And I put up one chart here to show the history. For those of you with a little bit of gray hairs in the room, remember the days when we just come out with a 10G, like many years ago, so that we are actually breaking the record for high speed, right? 10 gigabit per second. We actually built a product with 4 lanes of 2.5 gig. And this is the good old days we remember in the Z-Pack, X-Pack, X2, and actually several generations of 4 by 2.5 gig optics. But what happens is once the industry sign on to single lane 10 gig, you can see we never look back. All the products shipping in the industry in 10 gig is all single channel. Basically, we actually have a problem with dealing with end of life of these 4 by 2.5 gig. They're still there, but you don't remember them anymore. If you're looking at how the 100 gig optical solution evolves, just running through this now. The SR4, I don't think there's a lot of changes there happening. I think the SR4 still does well for a pretty short range. This is basically in the data center application. It's going to stay in the AOC area, serving a small segment of the application in connectivity. If you're looking at a PSM4, this is going to migrate over to so-called DR. Basically, you're going to see a single channel, 100 gig, and going 500 meters. And then if you're looking at a 2 kilometer so-called FR, currently served by CW4, and this is going to migrate over so-called 100G FR. So they will serve the 2 kilometer reach. And then if you're looking at the last leg, even the 100 gig LR form, eventually we will transition over to 100G LR as well. So we can see on the right side, basically a single element of optics and single actually technology foundation allow you to address all these different reaches. You don't have to see a very big number of alphabet soup to actually support 100 gig. And this is actually served a good efficiency in the CMOS industry as well, because one piece of digital signal processor can serve all these different markets. It's just up to the system users or end customer to decide if they want a 500 meter 3dB link budget or they want a 6 dB link budget to serve 10 modules. So this is sort of the foundation for us to move forward. And then if you're looking at how to lay them into the same network diagram we have in the data center. So you see in this new deployment, you see all the layers of optics, particularly in the single mode, that is served by the DR, FR, then we are talking about we need to transition over to 400 gig. This is now already in discussion phase with the end web companies, particularly the large data center customer really start to look at the next generation switches serving the 12.8 terabit per second capacity. They're going to need the 400G optics to go with it. So you see this transition over from 100 gig to 400 gig in the switching fabric layer, and this is coming. So we had to prepare for that. And if you're looking at how we actually evolve, today there's actually IEEE definition for several flavors of 100 gig already. But we do believe, as Andy actually said earlier, IEEE is a little bit slow in migrating with technology needed to make the transition over. So we'll see actually more flavors coming up. In the multi-mode area, you start to see from SR16 to SR8, and there's actually a new type of discussion about so-called SR4.2. Again, this is another acronym you have to remember, but the 2 after 4 actually means you start to resort to a level of multi-mode WDM, so you actually can continue to use the 4 pair of fiber instead of 8 pair of fiber. On the single mode side, I think IEEE is smart enough to actually adopt a DR4 already in the first generation of definition. So I think that DR4 is going to stay. And we believe they made a mistake about defining the 2 kilometers. So it's actually defined as 8 lanes. And we believe that 8 lane is going to need to transition to 4 lanes. 8 lane, when you have 8 set of optics, you had a package, and you had a making very high volume manufacturing, going to make it very expensive, and its power burn going to be very high. And we believe this is going to be migrate over to 4 lane by the time we actually deploy 400 gig optics for data centers. And 10-kilometer reach going to be more challenging. So the 100 gig lambda SA going to take the challenge. We're going to define a 10-kilometer flavor of domain optics as well. So this is wrapping up 400 gig inside data center solutions need. If you're looking at how then they deploy, again using the same network diagram, you're going to see the 400 gig DR4, FR4, LR4 going to be deployed. Depends on how the customer needs it in terms of application to their